So when you look at our course outline here, we'll begin by looking at definitions, and of course under definitions here we'll be looking at climatology, climate, weather, meteorology, and others. And then after that we shall move on to look at the Earth's atmosphere, where we'll be looking at the components of the atmosphere in terms of the mass of the atmosphere, the structure of the atmosphere, and then the importance of these elements in the atmosphere, as well as the atmospheric profiles or temperature profiles, and then their significance in climatology. Then we will also look at weather and climate. Here basically we'll be looking at how do we measure temperature and the other elements of weather. And then climatic classifications, what we call climatic classification schemes, each of them looking at its strengths and weaknesses. And then we shall look at the factors that influence climate, because we know that climate is not homogeneous all over the Earth's surface. So here we'll be interested in knowing which factors do influence this, bring about this heterogeneity in terms of climate. Then we shall also look at the radiation and heat budget. We'll be looking at solar radiation, terrestrial radiation, atmospheric energy budget, as well as what we call radiation balance. And then we shall look at atmospheric saturation, scales of atmospheric saturation, laws of horizontal motion, vertical motion, features, and then the seasonal variations in atmospheric conditions. Number 7, we'll look at the weather producing systems. Here we'll be looking at air masses and fronts, when we shall be looking at the concept of the ICZ and cyclones and anticyclones. Then 8, we'll look at the water balance and the hydrological cycle and its relationship to atmospheric saturation, to general saturation. And then lastly, we'll look at some aspect of climate change, because it's one of the new things that has come up, the new paradigms. So we need to understand what climate change is and what's the difference between climate change and the climate variability. So when we talk about climatology, we define it as a science which deals with the study of the atmospheric behavior and the resultant climatic patterns. Atmospheric behavior is the key word here, and then the resultant climatic patterns. Or in simple terms, one would say it is the scientific study of climate, a science that deals with the study of climate on the surface of the earth by analyzing the spatial distribution of atmospheric phenomena. So we realize that here the field of play, the laboratory here, is the atmosphere. That is the focus of the climatologists. The meteorologist also looks at the atmosphere, but meteorology is the scientific study of physical phenomena and the processes that work in the atmosphere. The difference between climatology and meteorology is that in climatology we study elements of weather and also the factors which influence their distribution and the recording of these. A meteorologist does not look at the spatial distribution, does not account for the why, how, and the why, but looks at what is there and then gives you conclusions. But in climatology, we should look at those the elements of weather, the behavior of the atmosphere in terms of its horizontal distribution as well as the vertical distribution. And then we are able to account why do we have high temperature here and low temperatures here. Why do we have more rainfall here and less rainfall here. That is what differentiates a climatologist from a meteorologist. But otherwise, generally, what the meteorologist studies is what the climatologist also studies, but only that the climatologist goes further to account for that behavior. Weather, on the other, weather is defined as the state of the atmosphere at a given time and place. I know when we were growing up, we used to define weather as what? Yeah?
The daily condition of a place.
The average daily conditions of a place, you know, the day-to-day conditions. But you know that weather is not daily. Weather is not day-to-day. Right now it's very sunny. But you know very well here for the time you've been in UCU that sunny weather can change within just 30 minutes. It will be pouring. Right now it's very calm. You even see that not even trees are shaking. Very calm. But it can become windy in just 2 minutes. That's why weather elements of weather are recorded on a 2-minute basis. After every 2 minutes, they give you an update at a weather station. These are modern weather stations. So you realize that weather is not the daily like we used to define it in primary school. Weather is not day to day, but it's the state of the atmosphere at a given time and place. Right now the atmosphere is sunny, calm. In terms of temperature, it's hot. In terms of sunshine, it's sunny. In terms of wind, it's calm. Rainfall, no. Clear blue skies, no cloud cover. But that can change in just minutes. And therefore it wouldn't be right for you if someone asks you tomorrow that what was the weather yesterday, and you say yesterday's weather was this, as if it was one first thing the whole day. It's not always the case. Sorry? Sometimes it happens. But we cannot. But what we are bringing out here is that weather can change, even within a minute. So for you cannot define it as daily conditions of a place. Yeah? It can't be daily, but it's at that specific time. That's what we define as weather. So weather is temporary. In other words, that's what it brings out. Same temporary phenomenon, it can change. On the other hand, when we talk about climate, we are talking about the average of weather conditions of a place recorded for a long period of time, usually over 30 years. And therefore it clearly brings out the concept that climate is somewhat permanent. Much as weather can change within the blink of an eye, climate, you cannot say that the climate today is hot. That is not climate. Climate is not, I know when you're in high school, you used to make fun that open the window so that the climate can come in. It is not, that is not correct. Because climate is somewhat permanent. You take the conclusions, the additions. If today the temperatures are 35 at 27 degrees Celsius, average. Tomorrow you add 27 degrees Celsius. The other day 29, the other day 25. Over a period of 25 years, 35 years, 30 years, 20 years, then you can deduce that the weather, that the climate of Uganda Christian University is a humid tropics. Because you have information of a long period of time. But for weather, it can change. I've told you, we usually receive afternoon rains here in UCU by around 2. But when during the daytime from morning to that time, it's very hot. So weather can change. Weather is temporary. So climate tends to be permanent, unlike weather, which is temporary, and it covers a wider area. You know, you see here is a small place, but you can be here in east. I don't know that this is the east end or the north. This is the north, the south. You can be in the north end of UCU here, when it's very calm like this, but you move take back, you find when it's windy, because the wind is moving from Besania Hill down to the swamp, or it's moving down from the wetland up to Bethania Hill. So, but climate covers a larger area. You'll find that if you're describing climate it can be climate of central Uganda. That's why we talk about the Lake Victoria shores. Lake Victoria shores are stretching all the way from, Melissa, you come from which side?
Yes.
Which district? Luhampara. Yeah. Luhampara is quite far off. But if you're talking about district here. Is Sinjo is closer to is closer to Rakai? You may find that even Sinjo is part, including part of, because that system, that is still Victorian system. So you might find that when you're talking about the Lake Victoria Basin, you begin all the way from there up to Busia. And you're describing climate of that entire region. But weather cannot be for that region. Yeah. These days, you know that it can be raining in Kampala city there. When you hear it's shining, it's very hot. You can call home in Bugisu and they tell you, here it has been raining since last night. When it's here, it's very what? That's weather. But climate, climate will cover the entire eastern Uganda. You say across the Nile, all the way up to Teso Plains. It's climate. It covers a larger area. The elements of weather and climate are the same, and therefore they include things like precipitation, temperature. Precipitation, of course, here we're talking about precipitation is the bigger word. Rainfall is an aspect of precipitation. That's why here we're using precipitation. Because if you say rainfall, that means you've scaled it down to a form of precipitation. But we know that under precipitation we have rainfall, we have snowfall, we have sleet, we have hail. All those are under what? Precipitation. Then we have temperature. What is the temperature? The degree of what? Give me the primary three definition.
Coldness or hotness.
What is the humidity? Humidity here we are talking about the amount of what? Water vapor. Atmospheric air pressure, we are talking about the weight. That's the air, the mass of air exerts onto a surface. We talk about wind. Wind is what? Moving air. And here in the terms of wind, we are looking at direction and speed. We talk about sunshine. Under sunshine, we look at intensity and duration. You've ever moved under the sun? When it's quite mild, you can walk from here up to Mukono without even experiencing any bit of sweat, because it's mild sunshine. But there are days when you can walk right just from Nkoyoyo up to dining, and you reach the other side when you feel like the body is melting. The sunshine is too intense. So in climatology, we measure that intensity. Of course, you know the instrument which is used to measure sunshine intensity. It's called what? The Campbell what? The Campbell Stokes recorder. Then we also measure duration of sunshine. Then we have cloudy cover. Under cloudy cover, you are talking about visibility. However, like I've mentioned, both weather and climate are made and found in the atmosphere. So what is the atmosphere? We are saying the atmosphere comes from a Greek word, atmos, which means an envelope. Atmosphere, therefore, is a thin envelope of air which surrounds the earth and is retained in place by the force of gravity. The thin envelope of air, that the moment you step off the ground, off the surface of the earth, there's that thin envelope. Why do we call it thin envelope? Because it's not too huge. I know you have never given birth, but have you ever been to labor ward? Have you ever delivered a goat or a cow? You know very well that the baby comes out of the body. Usually, this one I'll give the example. I'm very sure about the one of the animals, because I've never been to the labor ward. the calf or the kid comes out of the body of the mother inside some kind of a sack. That one is usually called a baby sack. And that baby sack surrounds the kid or the calf completely entirely. So if you have delivered that cow, you must quickly break that baby sack so that the calf now begins to breathe the oxygen. You get it? So just like that phenomenon of that baby sack, even the atmosphere covers, it envelopes the entire world. It's a thin envelope of air. It's like we have the world here, this is the world, and then around it, much change. Around it there is a sack covering it, but it's made up of what? Air. A thin envelope of air, which surrounds the earth, and you say it's retained there by the force of gravity. It is said to be thin because it's only about 50 to 100 kilometers. I know you must be saying 100 kilometers, that is too much. No, it's not too much. 50 kilometers from Mukono here, see, you don't even reach Jinja. You've already finished your 50 kilometers. From Mukono here, you only reach, I think, 100 kilometers, you reach Iganga. It's a short distance. But why are we using the concept of 50 and 100? Because we know that the world is not straight. The world is not straight like this. You've ever seen a globe? Huh? Yeah, in that office there. But that globe shows you, it depicts the structure of the earth. So around the equator, you see that the world, the earth is kind of bulges. So in areas around the equator, the upper limit of the atmosphere is 50 kilometers, approximately 50 kilometers. But towards the poles, the North Pole and the South Pole, because the earth quite some kind of narrows down, so to move from here, it's like when you draw something. Sorry, I'm not using my office, so I don't have a lot of things to interact with here. If this is the globe, the world of that shape, so that shape is spherical, and then around it we have what we call the atmosphere. From here, where we have the equator, here to the upper limit of the atmosphere, we are saying it's about 50 meters. But from here to the upper limit of the atmosphere, this one is a longer distance than this. Here you're saying it's 100, it goes up to 100 kilometers. That's what I'm talking about. Here, because this one is bulging, maybe I've not even drawn it more perfectly. It's bulging like that. It bulges around the equator. From here, the distance from here to here is not the same as from here to here. Are we together? That's what we are talking about. That's what brings about the difference, the variation in terms of the length or the width of this atmosphere at the equator and at the poles. Because at the poles, the distance is longer and than at the equator, where we're talking about a shorter distance. The farthest limit of the atmosphere by international standards is at 100 kilometers. That's the farthest you can go. Then someone would ask you, if you're saying that the atmosphere is just, the upper limit is at 100 kilometers, above it, what is there? Above it, we have what we call space. You've heard about space. When Americans are talking about space missions, the moment you get out of the atmosphere, you are into what we call, and the phenomenon within space is different from the one within the atmosphere, because the behavior of the atmosphere is different compared to space. We shall look at the structure of the atmosphere and you will understand more. about it. So the Earth's atmosphere is said to contain a mechanical mixture of gases and not chemical compounds. It's a mechanical mixture of gases because these gases do not produce new ones. It's the same gases which are there. Well, if it's chemical, then you would realize that there will be new production of new gases. But here, it's the same. Like you've been studying since primary, that the atmosphere is made up of which gases? 1G, nitrogen, oxygen, carbon dioxide, etc. etc. Not even a single gas has been added to that atmosphere. Even when you're talking about the concept of global warming, it's that the activities of man are interfering with the composition of those gases, but it's not adding new gases. Because if man adds more carbon dioxide to the atmosphere, we know the amount of carbon dioxide in the atmosphere is 0.03. That's the amount of carbon dioxide in a normal atmosphere. If man adds more, and this becomes 0.05, disorganized it. If you were Bazungu right now, you'd be knowing your carrying capacity, the carrying capacity of your stomach. How many calories do you eat for you to feel satisfied? But for us, we don't follow those things. Listen, sometimes you eat. Then when you get up, you say, "Hey, you mean I was overeating?" You are struggling to walk. The Europeans do that. They measure their food in quantities. They measure. They know the amount of calories per meal. That if I'm taking breakfast, this is the amount of calories that I'm eating. If I'm taking lunch, this is the amount of calories. And in terms of protein, in terms of carbohydrates, but for us here, it's about feeling full. So it is composed of a mixture of gases which are invisible. Of course, have you ever seen gas? Have you ever seen wind? Have you ever seen air? Have you ever touched? You just feel it. They are invisible. And a large number of suspended microscopic solid particles, collectively known as aerosols. Aerosols, they are within the atmosphere there. But we don't see them. Sometimes you feel it on your skin. If you move from here to Tech Park and you rub your face and you see dust on your face, where did that dust come from? Did you encounter any dust along the way that there is a huge truck which came and passed? Huh? At the end of the day, when you rub your face, you feel the salt. Huh? Have you ever experienced this? Where did the salt come from? The salt is in the atmosphere. It's aerosols we are talking about. And the sweat. So we have these aerosols. So the Earth's atmosphere, we are saying that it evolved into its present form and composition about 400 million years ago. It's one of the most important things that must be to the world or to the earth and to man in particular, because it protects man from the dangerous sun's rays. This sun here, thing we call sun, produces a lot of energy in different forms. This one, when it sends a ray of light, one beam, this one beam here has got a lot of things. We have gamma rays, we have beta rays, we have ultraviolet, we have visible light, we have infrared, we have thermal, we have microwave, we have radio waves, we have within that. And all of them are not necessary. Some of them are dangerous to man. Like you've heard about the ultraviolet radiation being dangerous to man because it causes what? A skin burn. The ultraviolet. what the atmosphere does is that it helps to absorb some of that dangerous radiation. How does it absorb? Because within the atmosphere we find what we call the ozone layer, the ozone, or the ozone gas. This ozone gas here reacts with this short wavelength energy, short wavelength but very dangerous energy, like ultraviolet. But then it also allows the longer wavelength radiation, like the visible and others, to go through it, because we need this longer wavelength energy. Because if this longer wavelength was not there, then you would not be receiving radio there on your phone. You would not be receiving TV there in your decoder. You would not be doing so many things. You would not even be seeing. You know very well that light is the one which aids us to see. That's why within this spectrum, there is what we call visible light. This is the one which is detected, can be detected with your naked eyes, and it's the one which enables us to see. If right now it became very dark, there was no sunlight, when you are moving out of this room, what would you do? You'd be like, you want to see where the objects are so that you avoid them. Because your eyes cannot produce its own energy. The eyes depend on what's there. So if this visible was not reaching, you would not be able to see. That's why this atmosphere is very important to man. We also take note that the atmosphere has no abrupt cutoffs, but it slowly becomes thinner and fades away into space. You know, this is what this comes in when we talk about the concept of a region in geography. That we don't have that abrupt, that as I am moving like this, then abruptly the atmosphere has stopped. No, it does not happen like that. But it fades away, like you see how rain usually happens. It's very rare to find an abrupt stop of the rain. That as you're moving from Mukono to Lugazi, you are receiving 10 millimeters of rainfall. 10 and 2, stop, 10. You say 10, then you go to 8, you go to 7, you go to 1, you go to 0 point, then no rain at all. That's what usually happens. So even with the concept of the atmosphere, that's usually happens. There is no abrupt cutoff. And that's why when we are describing the structure of the atmosphere, we talk about transition zones. The transition zones. That between the troposphere and the stratosphere, there is a transition zone called the tropopause. There is a tropopause. There is also no definite boundary between one layer and another. That for you to say, you know, when you are illustrating things here, sometimes they look so simplistic. You will illustrate something and you put a line that this marks this is troposphere, this stratosphere. But in reality, there is no definite line like this, which you define, because temperature. What brings about this variation, this what we call vertical temperature profile. This classification of the atmosphere, vertical, is based on temperature profile. And yet we know that temperature is a continuous phenomenon. Temperature does not break. You move out of this room, for example, it may be 25 degrees Celsius. You will continue with your 25, it may be go on reducing 25, 24.9, 24 like that, or increasing 24.5.1 like that. Because temperature is continuous. Temperature is not discrete data. It's not discrete, so it's continuous. If you're looking at something like land use is discrete. Because you have planted your beans and you know your garden stops here. You planted your cassava and you know your garden stops here. You planted your potatoes like that. So the boundaries are there, well defined. But temperature is not like that. It does not have those well-defined boundaries. The Earth's atmosphere consists of gases which sustain life found on the Earth. What is the most important gas to man?
Oxygen.
Oxygen. If right now we run out of oxygen in this room, they will find dead bodies. But that's oxygen. Its reservoir is in the atmosphere. This oxygen is important to man. This oxygen is important to animals. Nitrogen is important to man. Nitrogen is important to animals. Argon, carbon dioxide. You know, carbon dioxide on the outside it looks like it's a useless gas, but it's one of the most important, even more important than nitrogen in the atmosphere.
To man?
Yes, to man. Carbon dioxide. It looks quite useless, but it's one of the most important gases. It may be next to oxygen. Because it influences the behavior, it's one of the most important as far as the behavior of the atmosphere is concerned. You know, did you know that without the presence of carbon dioxide in the atmosphere, the Earth would be frozen? It would freeze, the Earth would freeze.
So carbon dioxide.
Carbon dioxide helps to regulate atmospheric temperature because it traps heat in the lower atmosphere. It's the one which traps the heat in the lower atmosphere and therefore helping to regulate the temperatures. Without its presence here, the Earth will be frozen. Hydrogen, ozone, etc. All these are collectively known as air. What is the composition of the atmosphere? We say the atmosphere, dry and pure, is composed of gases only, while a normal atmosphere is composed of gases, suspended solid particles like salts, dust and smoke, and then water vapor. Dry and pure atmosphere is made up of only gases. Normal atmosphere is composed, normal, what we call normal. You know, there's a difference between dry and pure and then normal. So normal atmosphere has gases, has this aerosols, it has water vapor. What is the composition of gases in the atmosphere? Of course, we know that nitrogen takes up the highest percentage at 78%, oxygen at 21%. So the biggest chunk in the atmosphere is nitrogen and carbon dioxide and oxygen. Oxygen is 21%. Nitrogen is 78%. When you add up these two, you get 99%. Two gases make up 99%. But in terms of climatology, in terms of climate, the behavior of the atmosphere, this 99% is not the most important. The remaining 1% is the most important. But then someone may wonder, how does it come about like that? Maybe, you know, I'm a believer. God created it like that. And we, as inhabitants of the world, should endeavor to maintain that composition. Leave the nitrogen at 78, leave the oxygen at 21, leave the rare gases at 1%. The moment this increases beyond this 1%, what is the normal temperature of a human body? What is the normal temperature of a human body? You check a temperature every day when you are entering campus.
36.
What's the normal temperature? What do you think would be the that would raise an alarm at the gate What temperature would raise an alarm?
37 and above.
Hmm? Because once we know that the normal human body is supposed to measure at least up to 37 degrees Celsius, once you come with temperature more than that, they know your body is not what? Then they will assume you have a fever. So, nitrogen 78, oxygen 21, argon 0.93%, carbon dioxide 0.03%, neon 0.0018%, helium 0.0005%, krypton 0.000114%, xenon 0.0009%, ozone 0. Even ozone, much as we emphasize its importance, God created it at 0.0006%. Hydrogen 0.0005%. That is the composition of the atmosphere in terms of the air, in terms of the gases. So we note here that although oxygen and nitrogen are the most dominant gases in the atmosphere, water vapor, carbon dioxide, and ozone are the most vital climatologically speaking, even when they exist in very small quantities. Carbon dioxide, for example, is used by green plants. How do green plants use carbon dioxide? Is used by green plants through a process known as which process? Photosynthesis. What is photosynthesis? You have forgotten. The process by which green plants manufacture their own food. Therefore, we note that carbon dioxide is a building element of all living things. But then we take note that its importance is not so much as far as food formation is concerned, but rather in controlling the environmental temperature. One thing you take note of is that carbon dioxide is a greenhouse gas because it allows the incoming shortwave solar radiation from the sun to reach the Earth's atmosphere, but also absorbs some of the outgoing longer wave radiation, and it helps to regulate the environmental temperatures to a level where water is largely in liquid form. That's what I told you, that if the carbon dioxide was not in the atmosphere, the seas and oceans would be frozen. People who have ever been to arid environment, they will tell you that at night it's very cold, near freezing level. During daytime, it's very hot. They will tell you the temperatures are over 45 degrees Celsius, 45 degrees. At night, they will tell you the temperatures in the arid area are 10 degrees or even 5 degrees Celsius. This phenomenon is attributed to clear skies. The clear skies. In that scenario, if the carbon dioxide was not present, which traps the outgoing terrestrial radiation, because when the terrestrial radiation is leaving the atmosphere, there's the good surface of the Earth, going back because the Earth absorbs during daytime and releases at night. But what helps to absorb that escaping heat is the carbon dioxide. Once the carbon dioxide is not present, then all the heat is going to be lost in the upper atmosphere, bringing about freezing temperatures here at the lower atmosphere. So carbon dioxide is very vital. It's because of carbon dioxide that temperatures of the world are largely in the range of 30 degrees Celsius. When we say that the average temperatures of the world average we talk about 30 degrees Celsius. Average. Take the equatorial region, take the temperate region, take the desert, take what? On average. I know we have these ones, which the desert suit, the highs of 37 and beyond. We have the polar to negatives, negative 20 degrees. But when you take it on average, we are around 18 degrees and 30. Without oxygen, without carbon dioxide, the world will be cooler than it is today. We know very well that there has been an increase in carbon dioxide in recent times in the atmosphere, of course due to combustion of carbon, because when you burn carbon, you produce carbon dioxide gas, and this carbon dioxide gas, of course, is very important, is very detrimental to the atmosphere. I say that God created the atmosphere with 0.03%. When we man, through our lugezigezi, do a lot of things that add carbon dioxide to the atmosphere, we are offsetting the balance. You've ever eaten food which is not probably it's about to go bad? You eat it in the evening, even before you wake up, the stomach is telling you go to the toilet, because you offset what? The system. You put in something that is not part of the system. The increase in carbon dioxide in the atmosphere has led to global warming as temperatures increase, but also a reduction in carbon dioxide would lead to cold conditions and glaciation in the whole world. The whole world will become frozen. If I am talking about increasing this, but if this one also reduced to 0.01, there will be a huge effect globally. So what must we do then? Maintain the 0. What? It doesn't mean that they are stopping us from burning carbon. You can burn the carbon, but make sure that you maintain the green vegetation, because the green vegetation does what? Helps to do what we call sequester. Sequester is to remove.
So outside countries, those ones where there is glaciation, is it because they affect they reduced on carbon dioxide when they?
No. Now for the outside countries where it is happening, there is just a natural phenomenon. And we are going to study it here in climatology, because they are very far away from the sun. That's why they experience that. Even here in East Africa, where we are astride the equator, we know very well that we have snow-capped peaks, the Rwenzori and Kilimanjaro. But that's also a natural phenomenon, because we already say that the higher you go, Wanji? That is going to change very soon after this lecture. You may know that there is a difference that is no longer certain. You can't make a general statement that the higher you go, the cooler it becomes, because the entire atmosphere is not cold up there. There is a layer which is too hot, even hotter than the one on the surface of the earth. So what is experienced in those countries? Sorry?
They are far from the sun.
Yeah, they are far away from the position of the sun. You know that the sun moves, the position of the sun is between the Tropic of Cancer and Tropic of Capricorn. It does not go beyond this. Someone who is here is obscured from the sun. For us here, we are receiving sunshine at right angles, 90 degrees, because it's here. For them, they are receiving the sun at that kind of angle. In certain seasons of the year, there is completely no sunshine, because the sun is behind. When the sun is in the southern hemisphere, these guys here do not receive it. The sun, of course, does not move. We are going to know why. We are going to explain this. That's why we use the word apparent movement of the sun. Because what moves is the earth. The sun is in one position. But because the movement of the earth brings about the apparent movement of the sun, so at the moment, we know that the sun is in the southern hemisphere. And right now, it's winter in the north. It has just been severe winter. I think things are trying to warm up a little bit. Because the sun was here and northern hemisphere was here, nothing was being received. No sunshine.
So when the earth moves and the sun was behind it, does it appear somehow in the right direction?